Chemisters, this is Mrs. Vandelay bringing you 8.5 blank wall. This will be quick. This is all there is to 8.5. It says the explanatory power of the quantum mechanical model. This is the beauty of how the periodic table is arranged. This is how Schrodinger's equations work out so great. This is the idea of valence electrons. This is like tying it all together. It's a great thing. So the periodic law, the chemical properties of an element are largely determined by the number of valence electrons they contain. And the idea of a periodic law is that it's repeating, okay? So it repeats over and over again. So once we look at the number of valence electrons, we go 1, 2, 3, 4, 5, 6, 7, 8. It goes back to 1, 2, 3, 4, 5, 6, 7, 8 again. And that repetition is really important because the chemical properties will depend on it. So group 1A has a valence electron of 1. And look at lithium, sodium, potassium, rubidium. What do you know about these alkali metals? They have one valence electron. Each one electron beyond a stable electron configuration, so they're going to lose one electron to their reactions. As you may or may not remember, that they lose one electron in a very spectacular way. They're highly, highly reactive. All right, that's what they all have in common. They're highly reactive. And why are they so reactive? Because they all have one valence electron that they're trying to get rid of, okay? Look at beryllium, magnesium, calcium, strontium, barium, iridium. These are your alkali earth metals, all right? They have 2 valence electrons, so valence electrons is equal to 2 here, all right? And they are 2 electrons beyond the stable configuration, so they're going to tend to lose those 2 electrons. And they're also pretty reactive. They're not as spectacular as your valence 1, your alkali metals, but they still are fairly reactive. They're not explosively reactive, but they're still pretty reactive, okay? Because they're trying to lose those 2 electrons. They all have that in common. So what about your group AA or your group 18 non-metals? They're all called non-metals. They're all called, noble gases. They all have 8 valence electrons except for helium, which is 2. They have a full outer energy level and are very stable, and they're all unreactive. All right, so these have valence of 8. Except for helium, of course, I do know that. And because of that filled octet, they are all stable. So this valence electrons has so much to do with their chemical properties. They're either really reactive or they're not. You can say the same thing for the fluorine family, the group 17. They're all nonmetals with 7 valence electrons. They're trying to get that next electron to be stable like the noble gases, and they all have that in common. So this is the idea of the periodic law, that these chemical properties are largely determined by the number of valence electrons they contain. And guess what, folks? That's section 8.5. So I'll say it one more time. Don't wait to be great. Bye-bye.